Hello everyone, welcome to another class of Vidhai. This video is brought to you by Exams Vidhai. Everything is possible. Exams Vidhai is non-profit initiative by the students of IIITDM Kancheepuram to give free coaching and resources to the students preparing for national level competitive exams like NTSE and NMMS. In this video, we are going to learn about expansion of substances. Contents of this video. In this video, we are going to learn about the topics thermal expansion, expansion of solids, linear expansion, surface expansion, and volumetric expansion, and also expansion of liquids and gases. Now, let's get into the video. Expansion of substances. When the heat energy is supplied to a body, there can be an increase in the dimension of the object. This change in dimension due to rise in temperature is called thermal expansion of the object. So, why do substances expand when heat energy is supplied to it? As we saw in our previous video, when the heat energy is supplied, temperature of the substances rises, which in turn means that atoms are going to move faster with higher kinetic energy. When this happens, the atoms hit or collide with the walls or surface of the body with higher force. This in turn leads to increase in the dimension of the object, that is, it expands. Now, let's look into the expansion of solids. When a solid is heated, its atoms gain energy and vibrate more vigorously. This results in expansion of the solid. As you know, the solid is a very rigid object, so the atoms cannot move very freely. Instead, what they do is they vibrate more vigorously when they gain more energy. The extent of expansion is smaller in solids than in liquid and gases due to the rigid nature of solids. The different types of expansion of solids are linear expansion, superficial expansion, cubical expansion. Let us look into this one by one. Linear expansion. When a body is heated or cooled, the length of the body changes due to the change in its temperature. Then the expansion is said to be linear or longitudinal expansion. This is the formula for linear expansion, where delta L is the change in length and L is the original length, and delta T is the change in temperature, and finally alpha L is the linear coefficient of thermal expansion. SI unit of coefficient of linear expansion is 1 by Kelvin. So with this formula we can find the linear expansion of the object. So if we consider an steel pipe of length L, then let us consider the temperature rise to be 25 degrees Celsius. So the steel will have a alpha L with respect to it. So that alpha L multiplied by the 25 degrees Celsius into its original length will give you the change in length of the pipe. So similarly, we will next look into the superficial expansion. If there is an increase in area of a solid object due to heating, then the expansion is called superficial or aerial expansion. At temperature T, if you have an area of A, and if the temperature changes by T plus delta T, then the area changes by A plus delta A. So the formula is alpha A is equal to 1 by A into delta A by delta T. Here alpha A is the area thermal expansion coefficient and A is the area of object in meter square and delta A is the change in area in meter square and delta T is the change in temperature in Kelvin. So the SI unit of coefficient of areal expansion is 1 by Kelvin. Next, volumetric expansion. If there is an increase in volume of a solid body due to heating, then the expansion is called cubical or volumetric expansion. So when we have a initial volume of V naught at a temperature T, and when the temperature changes to T plus delta T, we finally have a total volume of V plus delta V. So here alpha V is the coefficient of cubical expansion. So its formula is alpha V equal to 1 by V, which is the original uh, volume in meter cube, and delta V is the change in volume in meter cube, and delta T is the change in temperature in Kelvin. SI unit of coefficient of cubical expansion is 1 by Kelvin. Now let us look into the next topic, expansion of liquids and gases. When heated, atoms in liquid or gas gain energy and are forced further apart. The extent of expansion varies from substance to substance. For a given rise in temperature, a liquid will have more expansion than a solid, and a gaseous substance has the highest expansion when compared with the other two. The coefficient of cubical expansion of liquid is independent of temperature, whereas the coefficient of expansion in for gases depends on the temperature of the gases. Next, we will look into the types of expansion in liquids and gases. There is two types of expansion in liquids and gases, that is real expansion and apparent expansion. If a liquid is heated directly without using any container, then the expansion that you observe is termed as the real expansion of the liquid. The expansion of the liquid apparently observed without considering the expansion of the container is called the apparent expansion of the liquid. So basically, when you heat a liquid or a gas inside of a container, the solid container will also expand, but that will be in a lesser extent compared to the liquid and gas. So that is the major difference between this real expansion and the apparent expansion. Coefficient of real expansion is defined as the ratio of the true rise in the volume of the liquid per degree rise in the temperature to its volume. Coefficient of apparent expansion is defined as the ratio of apparent rise in the volume of the liquid per degree rise in the temperature to its unit volume. The SI unit of coefficient of real expansion is 1 by Kelvin, and the SI unit of apparent expansion is also 1 by Kelvin. I hope you all have understood all the topics that was discussed so far in this video. In the next video, we will be seeing about the fundamental laws of gases and the ideal gas equation. So, thank you for watching. We will meet in the next video. Please check the description for the lecture notes and feel free to comment if you have any doubts. Thank you.